Pythagoras himself was killed by a bunch of angry villagers. I'm not sure why. I don't know if they were scared of him because he was a smart dude or because he was a cult leader, but he was killed. So why do I call it Pythagoras' revenge? I just sounded cool. He didn't really get revenge other than the fact, here's the little bit of a revenge he got, is his name lives on forever, right? Nobody knows the names of the people who killed him. Pythagoras' revenge, the goal is to find the length of a missing side of a right triangle. That's goal number 1. Goal number 2, to find the supplement and complement of a given angle. Goal number 3, to find a coterminal angle. Goal number 4, to set up a function involving the Pythagorean theorem. And goal number 5, find the center, radius, and graph of a given circle's equation. So what does the Pythagorean theorem say? Well, we've got the given, which is a right triangle with sides of length A, B, and C. The shorter sides are called legs of a right triangle, and I've denoted them with length A and B, right? The long side, what do we call that? The hypotenuse, yeah, and we call that side C. What does the good old Pythagorean theorem say? A squared plus B squared equals C squared. You may or may not have seen a proof in the past of this. You may or may not care, but you should care. You should care, especially if you're going into a STEM discipline, you should ask why things are true. And I'm going to show you the fastest and easiest to comprehend proof of the Pythagorean theorem that I know. Using a drawing program, I created this right triangle. There's the right angle here, and 8 copies of the same right triangle. These are all congruent triangles. They're just rotated one way or another. Now I'm going to drag these triangles into place to create 2 figures, and we're going to analyze these figures to convince you that the Pythagorean theorem is true, just in case you didn't believe me. Okay, notice I've created 2 groups of the figures here, and I want to look at the outline of both of these figures. I'm going to highlight them both in black. There we go. Convince yourself that both of these figures are in fact congruent squares with sides of length A plus B. Now focus on this smaller square inside the left-hand big square. It has area A squared because its dimensions are defined by the smallest side of the right triangle. So this area in white is A squared. Now this area of this bigger interior square has got to be B squared because its dimensions are defined by the side of length B from the original right triangle. So that the total area in white here is A squared plus B squared. Now focus on the right-hand 4-sided figure inside the big square. This is also a square. You'll have to think about why this has to be a right angle, which makes this a square with sides of length C, the hypotenuse of our right triangle. But once you realize that that's a right angle, it's easy to come up with the interior area, which is C squared. So the total area in white here is C squared. But the total area in white in both figures has to be the same because both figures were created by the original copies of the original triangle without overlapping. So that means that A squared plus B squared is equal to C squared. And that completes the proof. So this is really important, you guys. When you're doing the homework, do it on a separate sheet of paper. Show all your steps because you're preparing yourself for the exam when you do the homework. By and large, the homework questions the exam questions will look like homework questions, and vice versa, I suppose. So here's number 1. In the following figure, find the length of the unknown side of the triangle. Give an exact answer and an answer correct to 3 decimal places. So I want to work through this with you because there are some quirks that you have to learn with WebAssign that are frustrating at first, and then you get used to it, and it's no big deal. This is about the easiest Pythagorean theorem problem you can think of in terms of applying the formula, because you don't actually have to solve for x, except maybe for taking the square root, right? So what does the Pythagorean theorem tell you that x squared is going to equal? Right, so that's going to be 6 rad 2, the whole thing squared, if we think of this as a, I guess, right? Plus what? Plus 3 squared, or 9, right? Okay, so we get x squared is equal to, okay, you have to square this guy and square this guy and then multiply, right? So that's 36 times 2 or 72. So that's going to be 72 plus 9. Okay, what's 72 plus 9? 81. Isn't that interesting? Okay, if x squared is equal to 81, what is x? 9. Okay, it randomly generates problems, so there might be 5 or 10 different versions of this problem. So when you do this at home, you might get different numbers. You're going to solve it the same way, but you'll, in all likelihood, actually get different numbers. But I'm glad they gave us this particular one, because if you're not careful, when there's no square root in your answer, and you don't plug it in right, even though you're right, it'll mark you wrong. So, I mean, if you think about it, look at what they're having you fill in here. They're having you fill in this box, right? And then, so they have this box times the square root, but there's nothing in the square root anymore, right? Because the square root of 81 turned out to just be 9. Okay, technically, there is something left in the square root. If you think of taking the square root of both sides when you're solving this, so the square root of 81, couldn't you pull out a square root of 81, which is 9, and what's left? What factor is left? 1. And this is kind of a homegrown problem. It's not from WebAssign. Some instructor invented it. So it's not very flexible, and it's not going to know what you mean if you leave the box underneath the square root blank. So you got to put in the 1, long story short, for it to mark you correct. So you put it in, you put the 9 out here, right? And then the 1 in here. Otherwise, it's going to mark you wrong. And then it also wants a decimal approximation, so you have to fill in that too. So I'll submit the answer and show you. It'll have green check marks on the exact answer, and then the approximate answer, I didn't fill it in, so it didn't give you anything. But you'd also want to fill in, run it through your calc. Well, actually, that would be 9. But again, let me emphasize, when you're doing these problems, work them out just like you see me do, except, well, you could use your computer, I suppose, if you have like a Surface or an iPad. But on paper, for most of you, work it out just like this. Show all the steps, because guess what? When I grade your test, if you don't have the right answer, I'm going to be grading your work that you showed and give you partial credit if you have something that's correct. And let's say you just said, you had a mental block or something. You said you did everything right except you said the square root of 81 is 8 or something. You'd get most of the credit, wouldn't you, partial credit-wise? Except if you don't show the work, how much credit can I give you? Nothing. If you just put x equals 8, what could I do? So when you're doing the homework, practice it like it's a test problem. Show all the steps just like I do in class. If you're not sure how many steps to show, go to the notes. Most likely, I've done a problem similar to what you're looking at in the homework, and you can use that as a guide as to how many steps you show.